fairly easy to do. Equatorial mount though, it has all these advantages that it's easy to track the stars and you can take photos with them and all that, but they have a lot more work. You don't just take them out and set them up because it won't work. Now we saw that picture before with the stars, right? There's the south there, and everything rotates in that direction around there. All the stars will do arcs in the sky, which if you're here for an hour or two, you'll notice that all the stars will slowly move in that direction. That point up there, which we don't have, Polaris, which this picture has, stays pretty much in the same spot. We don't have a star that's for our South Pole, unfortunately. But basically, if you point that little pivot point on the telescope, so it's in line with that spot in the sky that doesn't move, and the optics move around that point. So if the motor moves it in that direction, it will follow the stars, and if it's perfectly aligned, it will follow them all night. And nothing will drift out. If it's perfectly aligned, you can put a telescope onto a star and come back 6 hours later, and the telescope would be way over here, but the star would still be in the middle, exactly the same spot. So the first thing you have to do, they have an angle, which is basically the angle that the telescope points up at. And that's the latitude where we live. Melbourne's about 38 degrees. So set it about 38, you're ready to go. You only need to set that once unless you move to Darwin or something like that. So you just set that angle, then you're ready. Then you need to find the South Pole. You get out your compass. Unfortunately, a compass will show you where magnetic South Pole is, not true south. So if we had a compass here, it would point south somewhere in that direction. The true south, the real south, is actually to your left when you're facing south in Melbourne by about 12 degrees. Right, 12 degrees is about sort of that much, something like that. You get used to it if you sort of do it a couple of times, you have a good feel for it. I put my telescope down and I know my fence runs directly east-west, so I point it directly at the fence and then I turn it 12 degrees and it's close enough. For just normal viewing, it's just got to be close. So you've got to make sure that you can find where the real south is. It has to be reasonably close. And of course you have to level the tripod. There's no point in getting all set up and the tripod sitting like this because it won't work. It has to be level so that when it turns around this point. So you can see so far there's quite a lot of setup. That's one of the biggest problems. People buy cheap telescopes. Quite often reflectors like this are sold with an equatorial mount. And people say they can't find anything because if you don't set it up properly, an equatorial mount is useless because the stars will be moving in this direction and your telescope is turning in this direction. So as the stars go this way and you turn the little knob, the telescope goes this way. And so your stars get even further and further out. So you do have to do at least a crude alignment like this. So this is my mount at home. Pointing that towards the fence, I have my compass. You can see the compass is pointing off to the side slightly. So that's magnetic south. The actual real south is in the direction that I've pointed my hand. So again, pointing towards the south, to the left, about 12 degrees. So when you've got the compass, you just look at the point that's 12 degrees to the left of south, and that's where you point your telescope. It usually has a leg that they call the north leg, which in the southern hemisphere is the south leg. It'll have an N on it, which means you point it south. And you just point that. That's also usually the one that when the telescope's just sitting there, the counterweight will be sitting directly over that leg. When you've got one, you'll sort of, a lot of these movements will appear a lot more obvious. So you can see here, this is my south leg. The telescope mount is just sitting there, and this bar is just sitting directly above this leg, which is the south leg. And there's 12 degrees between where the compass points and where this leg basically points. Next thing, when you've got an equatorial mount, you don't have to do any of this with a Dobsonian or an altazimuth. So again, with an equatorial mount, there's still a lot more work to go. Some of these things you only have to do once and then you leave them there. You have to balance it. There's no point in setting it all up and then you loosen off one of the little clutches and the whole telescope folds over. So you have to make sure everything is balanced in all the different directions. So you have to swing it over to the side and adjust your counterweight so when you let it go, it just balances there. And you move the counterweight back and forth until it just sits there. And then you lock it in. That's done. Depending upon which way when you let it go, if it tips up so the counterweight goes down, the counterweight's too heavy, you've got to pull it in. Right? You can see an equatorial mount is a lot of work. But once you get this done, mine I've just put a little texter mark where the counterweight goes. You put a little texter mark where the tube goes. And when you set it up, wait to the texter, move the tube to the texter, all done, you know where the fence points, you just go, there's the fence, right, put the tripod there, put that in, line everything up on the texter and it's done. So it's a lot of work the first time. So if you do have an equatorial mount, you might want to copy it by notes. Some of this stuff is not even in the instructions. The next thing is, of course, the tube. The tube can go back or forth on the mount. You imagine if it's pointing too far forward, it'll just want to topple over. So you have to slide it back so that when you release the clamps, it doesn't just topple forward or topple back, so that it'll just sit there in a neutral position. So again, you get a feel for this, and when you get it right, you put a little texter mark where you want it. So when all this is done, you've finally got your equatorial mount all set up. If you were to release the clamps on my telescope there, and just release it so everything's just sitting there, nothing will move, it will just sit there. If you move the tube around, it will just sit there. If it was out of balance, you push it a little bit, it will swing right down. Scare the hell out of it in the process. So you have to have it all nicely balanced. But having said all these things, you can do it in about 5 minutes. Once you've got your little texter marks, about 5 minutes from when you decide to get everything out, then you're set. This case, like 30 seconds. If it starts to rain, just pick it up and bring it in. A mount like mine, it starts to rain, hopefully you know it's going to rain before it does, because you can't pick it up, it weighs more than I do. I can't lift it. So you want to move to an object and follow it. If it's an Altaz type mount like these, they often have these great big little curvy handles, and they're a fine adjustment. So when you're looking at a star, you'll see it drift off, and you'll soon get used to which one of these little knobs you turn and how far you turn to keep that star or planet or whatever in the middle. You get a knack of you sort of turn one twice as fast as the other one or whatever. You get used to it. On an equatorial mount, you generally only have to move one, because if this one here is set up properly, you only have to move that tube around a little bit as the Earth rotates to follow that star that's moving in that direction. The other one you don't have to move, because that's all set up. So this one here is only an adjustment. Well, this one here is an adjustment to get to an object. When you've got that star there, you'll only have to adjust, well actually it's this one. You move this one to get to an object, and then you just slowly turn this one, which will make it just rotate. So you'll just be standing there just turning this knob very slowly, and then it'll keep the star in. Instead of with the other one, you've got to use both hands. So it's a lot easier to follow, but a lot more work to set up. So as the object moves, you can see when you turn this little thing, there's a little gear here, and it just turns this around like clockwork, basically, but manually. Like it actually goes back that way. And it follows the star and turns this back over there to follow it. So the advantage of having a manual tool, it's easy, because you just got to turn these little knobs, but you do have to turn them. Once you get used to it, it's fairly easy. Disadvantages are, if you've got a manual mount, you have to know where everything is. If you want to find Jupiter, it's easy. Jupiter's the bright star out over there. The Moon's the big bright light pollution thing up there. Venus is out. It's probably set by now. It'll be a bright star. As it gets closer to Christmas, you'll see this bright star go higher and higher. That's Venus, so that's easy to find. If you want to find other objects, you're going to know where they are, because nothing's going to help you. The telescope's not going to help you. you can have a system called a push-to. And you can get that, this is on a Mead. This is an Australian company, makes these particular ones called Wildcard. Wildcard. And they, you can mount those onto your telescope after you bought it. And they're what they call a push-to adjustment. So you put this equipment onto the telescope, and basically you select what you want to look at from the little database, and you get little numbers come up on the display, and you move the telescope around until the numbers say 0, 0. And when they say 0, 0, your object's in the middle. So if you want to do another object, you pick it and you push it until the display says 0, 0. And as it moves, you just keep moving it to keep it on 0, and it'll stay there. And they work apparently quite effectively, and you can add them to telescopes after you've bought them. So the advantages are they have a very simple alignment. I haven't used one, but basically I believe you just put them down and you point them to a couple of objects and hit a 0, and then they pretty much are correct. Similar to the computer controlled one like I've got, a slightly easier procedure. And you can get them for about $600. Doesn't really make much difference what size telescope, a big one or a mid-sized one. It's the same cost, it's the same instrument. You just attach these little things to it and away you go. Difficult thing is, of course, that you've got to keep moving it. It doesn't move the telescope for you, so it's not automated. You've got to install it yourself if it doesn't come with the telescope, but they're quite easy. You just, particularly for a dog, you can usually just chipboard. You drill a couple of holes, screw in a couple of screws, maybe a bit of double-sided sticky tape, stick it all on, and it's done.